Now let's go further in the case. Let's assume that the quantity demanded is a function described as D of P and W, and the quantity supplied is a supply function in P and W. So W now is a shifter. It is not only a supply shifter or demand shifter. It is a shifter affecting both demand and supply. So suppose W is something not only affects supply but also demand. And we may have demand P W equals supply P W as the equilibrium condition. So at equilibrium, we may show that the price will be a function of the shifter. Okay, think about the reason, the reasoning behind this. Why this is an implicit function in W. So the demand, supply, and the price, the quantity. Now we have a change in W, assuming that the change in W makes the demand shift to the right and also makes the supply shift to the left. So this is the new demand and this is the new supply. And the initial equilibrium price is at P star. Given price unchanged and the change in W, a 1 unit change in W or a 1 unit increase in W, since it makes the demand curve shift to the right, so there is a gap here, and makes the supply change to the left, another gap here. So this, now if we hold the price unchanged, hold it constant here, and now the new quantity demanded, QD prime, and the new quantity supplied, QS prime, will make it an excess demand. It's a shortage, right? So we want to know how can we erase the gap? How can we erase the shortage? So when you were in your freshman year, the first year, in the principle of economics, you have learned, when there is more people want to buy the good and fewer people want to sell the good, there will be a pressure on price, make it going up, right? So that the new equilibrium can be reached and the gap can be erased perfectly, right? So now, let's think about this. So the equilibrium price will be a function in W, so that we put P by P of W here. And the change in W can affect the price, and the price can affect demand, quantity demanded. It's an indirect way. And there is a direct way. And indirect way, direct way. So if we differentiate the whole equation by W, what would happen? It would be partial D, partial P. Notice that, please note that now here we use partial rather than D. Because in this case, quantity demanded is only affected by P, right? But now it is not affected by P only and by W as well. So we use partial. So partial D, partial P, and chain rule, dP dW, plus the direct channel, partial D, partial W, equals partial S, partial P, dP dW, plus partial S, partial W. So this is the result by differentiating the whole equation with respect to W. Is that clear? I hope you can be familiar with this, the manipulation. So this is just the total differentiation. And now we want to know how about this term, dP dW. What is the size of the change in P caused by 1 unit change in W? We like to know this. And we have dP dW here, dP dW here. Okay? So let's move it, say, to the right. Now it would be partial D, partial W, plus partial S, partial W, minus divided by partial S, partial P, plus or minus minus partial D, partial P. Not difficult from here to here, right? You just rearrange the equation, the terms in the equation. Just rearrange. Is it clear? Now we want to know what's the correspondence from here to the diagram, from the equation, from the math to the diagram. Okay, remember I just told you a 1 unit increase in W makes the demand curve shift to the right. So what do you think about this term? Is it positive or negative? Positive or negative? Shift it to the right. So this term must be positive. Is that right? We just assume it. We assume the change in W makes the curve shift to the right. And also we assume that the change in W shifts the curve, the supply curve, to the left. So by assumption, this term should be positive or negative? To the left should be negative, right? And you see a positive minus negative, so it would be the absolute size of this one plus the absolute size of this one, right? So this term, this part, corresponds to what? Partial D, partial W is positive. Is that right? And this part corresponds to negative partial S, partial W, because we assume it to be negative, right? So you add these two lengths together as a total gap caused by the shifts in demand curve and supply curve. now we have understand the numerator here. What about the denominator? It's just the same as we described here. Okay? It's similar to that one. So partial S partial P, which means without any change in W. So partial S partial P is a move along the supply curve, right? It's a move along the supply curve. Is that true? So along the supply curve, when the price goes up by 1 unit, how many units change in the quantity supplied? So if this is 1 unit, if this is 1 unit change in P, then this quantity supplied will increase by this much. Right? So this would be partial S, partial P. And when the price goes up by 1 unit, what about the quantity demanded? The quantity demanded will be less. It decreased by this size. Okay? And what about the size here? It is partial D, partial P with a negative sign. Because this term is negative, we give it the negative term a minus sign or a negative sign makes it the absolute value, the size. Okay? So this, the size plus the size. So the sum of these two lengths means for each P, how many units in quantity can be in the how many unit of change in quantity by each unit change in price. Okay? So the total size, the total magnitude of change in P. So this is the initial equilibrium price, this is the new equilibrium price. So what is the size? It should be the ratio here, right? So this is what we want to know. What is the size changed in P by a unit change in W, the shifter? So this is the size. And also positive minus negative, positive minus negative. So both the numerator and denominator are positive. So the ratio is positive. And you see the change in P, the direction change in P is positive. Okay? So this is the case number 1 telling us a positive, negative. This is case number 1. So how many cases do you think there can be? Case number 1 is positive, negative, and case number 2 it can be positive, positive, right? Case number 3 can be negative, positive, and negative, negative. So totally there will be 4 cases. Alright? So case number 1, positive, negative. What about case number 2? If we make it case number 2, number 3, number 4, you make it positive, positive, negative, positive, negative, negative. So, positive, positive, okay? Positive, positive. And negative, negative, positive. Okay, I'll put it here. This is case number 1. And what about case number 2? Case number 3? Case number 4? So case number 2 would be like this. So the initial equilibrium point and the final equilibrium. And case number 3, negative, positive, negative, positive. Initial, initial. And negative, 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 negative. Initial, new. Okay. And what do you think about the denominator? Is it must be positive? Must it be positive or negative in the denominator? Positive or negative? The direction of the change of P in S. Once again, the direction of the change of S by an increase in P. Because of the law of supply, so this must be positive. Minus the law of demand, so this must be negative. So positive minus a negative. This term must be positive. And now, case number 1 is positive, positive, negative. So it's very clear, definitely, to be positive. What about case number 3? Negative, positive. If this is negative minus a positive, so it must be a negative one, right? Negative, positive, so it's negative. That's why you see is without doubt the price will change in this direction, going down. But case number 2 and case number 3, can you be sure whether the price should goes up or goes down? So you raise the gap. You don't know, right? We don't know. We don't know what about the price. It depends on the size of the change in demand curve and the supply curve. It's about the relative size. If the demand shifts more, the supply shifts less, then you will see the price goes up, right? But if the supply shifts more, then if the supply curve shifts more to the right, then the demand curve should shift to the right. Then the price will goes down. It depends. So we have no idea. Depends on the size. Then let's check. Positive, positive. A positive 1 minus a positive 1. So if the size in demand, the size of change in demand is higher than the size of change in supply, then the big positive minus small positive, right? It would be positive. So if demand goes up more, shift to the right more than supply, then you will see the price goes up. On the opposite, a small positive minus a big positive will be negative. Is that clear? And case number 4, negative minus negative. ambiguous, right? We cannot be sure. Negative, a small negative minus a big negative. What about a small negative minus a big negative? It would be positive, right? So if this is the small negative and a big negative, then the price will go up, right? Small negative minus a big negative, so makes the numerator positive. On the opposite, if the shift in demand, the size, the magnitude of the negative shift of demand, which means a big negative minus a small negative, then totally it will be negative. So you see the price goes down. Is that clear? So this equation may capture 4 cases. Case number 1, 2, 3, and 4. It depends on the sign of these 2 terms. Okay, so case number 1 could be the classic one, so that you can understand what this is about. Positive minus negative is a positive influence on demand and a negative influence on supply. And this part is partial D, partial W. This part is partial S, partial S, partial W with a negative sign. So we sum these 2 terms up to have the total gap caused by the increase, the unit increase in W, the shifter. And we like to know how to erase this gap. So by each unit change in P, we may erase the sum of these 2 lengths, right? So this is how many units of change in P can we erase the whole gap entirely. Is that clear? Okay, I'll give you 1 or 2 minutes to think about that. You may discuss with your classmates. Alright, let me give you a numerical example. A numerical example here. So, would you please tell me what about the equilibrium price P star? What would be the value when W is set at 0? 6 or 60? 60, right? So P star would be 60. When W equals 0 and quantity demanded equals quantity supplied, so it's 120 and 2P, so it's 60, is that right? And what about when W increase by 1 unit? What would be the new price, new equilibrium price? It would be 102 and minus 21, right? So it's 123 divided by 2. So it would be 61.5. Is that right? Alright, so the change in P would be 1.5, which is dP dW. Is that clear? And what about partial D, partial W? Partial D, partial W would be 2 minus partial S, partial W would be minus 1. So the gap would be 3. And by each unit change in price, so partial D, partial P, partial S, partial P would be 1 minus partial D, partial P, negative 1. So it's 3 by 2, and it's 1.5. Is that clear?